Welcome back, ladies and gentlemen. This is 1.29 Quadratic Relations. I did move some stuff around just so it's already revealed. The number of solutions. So this lesson is actually going to tie in a lot of what we've already learned. I wrote some notes down on the side just so that you could see them already, where the stuff is coming from. And once I reveal it, it'll be a bit more evident. The number of solutions. The zeros or x-intercepts of the relation y equals ax squared plus bx plus c are the solutions or roots of the equation 0 equals ax squared plus bx plus c. So whenever I'm talking about the solutions, I'm talking about the x-intercepts or the zeros. So there's a lot of words or terminology that just mean essentially the exact same thing. The quadratic equations have 0, 1, or 2 solutions. And I talked about this a little bit in the forum recently, and I even illustrated this a little bit. So I did already touch on this a little bit, but we're going a bit more in depth now. Whenever we see a parabola that has two zeros or two x-intercepts, like here and here, we see very clearly in the equation. So if we look at the quadratic formula from 1.26, what's under the square root of the quadratic formula, which is just b squared minus 4ac, if that's greater than 0, then that means we're going to have two solutions. Similarly, if it's equal to 0, then that means that we'll only have one solution, because it'll be negative b plus minus 0. So that means that there's only one solution in that case. Fun fact, if there's only one solution, that means that the vertex is your only x-intercept. It's not necessarily the y-intercept. In this case, it's all at the origin. This x-intercept could be moved anywhere. The parabola could be moved left or right, and you would have your vertex just at the x-intercept then. And then your y-intercept, of course, would be different. If you have b squared minus 4ac less than 0, that means if it's negative under the square root, well, fun fact, we actually saw this in one of our homework examples. We had square root negative 8. How do you take the square root of negative 8? Well, you can't. No real roots. So no real roots. So we just leave it as there's no real roots. That means that there's no solution. And that means that on the graph, the parabola doesn't touch the x-axis. Okay, so that's the quadratic formula. Now I want to look at the vertex formula, because we can also tell by just looking at the vertex formula. And in this case, it involves the variables a and k. So you remember for a and k, if a and k multiplied together is less than 0, so if a times k is negative, then that means that there's two solutions. So that means that either the vertex is below the x-axis and opens up, like in this example here, or you would have it flipped and the vertex would be above the x-axis, but it opens down. Our next example, you would have a times k equals 0. Well, if a is equal to 0, then the parabola isn't a parabola at all. If k is equal to 0, so this is kind of misleading. If k is just equal to 0, that means it only has one solution, because the vertex is on the x-axis at that point. It doesn't move up or down. Remember, whenever we talked about transformations, k moves the parabola up and down. So if k is 0, that means that it is sitting on the x-axis. And our final example, if a times k is greater than 0, then that means that it's either going to be the vertex is above the x-axis and opening up, or the vertex is below the x-axis and opening down. Now, this is a lot to take in, and I haven't really thrown any real numbers at you, so let's take an examination of some examples here. So first we have determined the number of zeros in each parabola. Here we have a standard form. So if you're given a standard form, you would plug in b squared minus 4ac. Remember, this is ax squared plus bx plus c. So you would just sub in a, b, and c appropriately, and you'd get b squared minus 4ac. So you'd have negative 6 squared minus 4 times 2 times 9, and you should get negative 36, which is less than 0. And remember, if it's less than 0, like we have up here, that means that we have 0 solutions, or 0 zeros in this case, if you want to get witty. Here we have the a value, or we have a vertex form for our second example. So in our vertex form, we examine a and k. If a times k is less than 0, we have 2 solutions. If it is 0, then we have 1. If a times k is greater than 0, that means that we have no solutions. In this case, 2 times negative 5 gives us negative 10. It is less than 0, that means we have 2 solutions. Because a times k is equal to negative 2 times, because it's equal to 2 times negative 5, which is equal to negative 10, and negative 10 is less than 0. Therefore, we have 2 zeros. So that's just determining the number of zeros or solutions that we have. If we go on to the next slide, we actually need to determine the x-intercepts. In this case, this is just review of 1.24. You guys have done tons of factoring at this point. We've done at least 2 lessons on factoring directly, and a couple lessons we had factoring already in it, so I'm not going to go super in depth. First, you start off by taking out a common factor, which is 2, because you can't take 4 out of 22. Then you can solve this using the box method. So what multiplies to 28 but adds to negative 11? And then you use your Xbox method to solve. I just jumped to the end here because you guys have seen factoring. If you don't remember this, you can go back to 1.24 and easy peasy, it's right there. Okay, so here we're at our 2 factors, or our 2 solutions. We know there's 2 solutions here, and we need to determine what they are to 2 decimal places. Now, to solve what your factors are, or not your factors, your zeros are, you have to set each bracket to equal 0. So 2x minus 7 equals 0. Well, that's just going to tell me that x is going to equal positive 7 over 2. That's one of my solutions. Another example, or the other bracket, has x minus 2, which just tells me that positive 2 is going to be my other 0. So there's my 2 zeros. You could convert the fraction into a decimal. I'm not going to hold that against you if you want to do that. That's all fine. Next, for the next example, it doesn't factor quite nicely. In this case, we would actually have to use the quadratic formula, which is why I'm using the computer for this, because the computer does this very, very nicely. You set it to equal 0, then you use your quadratic formula and plug it in. If you don't recall your quadratic formula, this is 1.26 that we did, our quadratic formula. So you can go back over that. This isn't anything new. So we've done this before. You know your quadratic formula. You know factoring. So 1.24 is fine. And that's just how you work through that. So you do negative 5 plus minus root 41 all over negative 4. So you do plus first, then minus, and you should get x is equal to about negative 0.35 and positive 2.85. And those are rounded to 2 decimal places. You could leave it as an irrational number or a fraction. However, the question does say round it to 2 decimal places, so I'm not going to be too picky on that, because you guys have been working pretty hard at accomplishing this. Next slide. So for our first example, it's just completing the square. Remember, the first step in completing the square is take out a factor of a. So we're going to divide both terms by 3 over 4. When you divide -3 by 3 over 4, you actually get -4. And then to figure out your next two values, it's half of this -4 squared. Half of -4 is 2. 2 squared is 4. So that's why you get +4 -4. And remember, when you're adding these in, it's +4 -4. If you shorten this or collect like terms, this would just be 0. You're really just adding 0 in this case. But then we factor what's in the first two here. And we'll have x minus 2 squared. And then we have to multiply that -4 by the a value and bring it out. If I'm going a little bit quick, you might want to look over 1.27. This is completing the square. You guys have done this before. That's why I'm moving through this quite quickly. And in this case, we're not actually looking for zeros. We're just looking for the vertex. We have h and k here. We have -2. So h value is +2 because that'll set the x value to equal 0. What's in the brackets here to equal 0. So if we had +2 for x, -2, that'd be 0 there. That means that 2 is our h value and -3 is our k value. There we go, right there. Perfect. Next example. This one's a little different. I'm not going to lie. It is quite drastically different. The way you actually find your vertex when you're given two zeros, I don't believe I've taught you this, so that's why I'm going to take this a little bit slower, is you find what's halfway between these 2 points here. So we have our zeros, which are -5 and +3. That's where our two zeros are. The x value of the vertex is going to be halfway between those two. So to find the x value of the vertex, or our h value, h is just going to equal 3 plus -5. I don't know why I reversed the order. You could have -5 plus 3 all over 2. We're just averaging out those 2 points. We're finding out what's in between, what's the exact midpoint. And the exact midpoint for h is -1 because 3 minus 5 is -2. -2 divided by 2 is -1. So now we know the h value. To find the k value, you just sub it into the original equation. So we go back over here, and we'll have, instead of y, I should actually write k. So instead of y, I'm going to write k, because we're going to solve for k. -5, I sub in -1 for my x value, because that's the x value of my vertex. We have +5 times -1 minus 3, which means I have -5 times 4 times -4. So we have -5 times 4 times -4, which is just -5 times -16, which is just +80. So, therefore, my vertex is at -1, +80. And that's it for that. You just take your average of your zeros, sub it back in to find your vertex, because it's going to be halfway, your vertex is going to be halfway between your zeros, your two zeros, and then you solve for your y value. For our final example of the first cycle, we have find the minimum value of the relation below. Well, we can't exactly just read it because it is some sort of fraction, and we'd be making too many assumptions. But what we can do is we can start by determining what our zeros are. And in this case, our zeros are just -2, +4. That means that our equation is going to look like this. And we don't know the a value, so we have to pick a point. And the point that I would pick here is our y-intercept. So that is the point 0, negative 10. And you sub that in for your equation here to solve for a. So we're going to end up with 2 times negative 4 here, because x is 0. 2 times negative 4 gives us negative 8. So that our a value is going to be negative 10 divided by negative 8, which means that it's going to reduce down to 5 over 4. And that's going to equal a. There we go. So we're off to a great start. And then we need to determine our h value. Because we know our zeros, we can figure out h is going to equal, so over on the left I'm going to write h equals 4 minus 2 over 2, which means that it's going to equal 1. So our 1 here is the x value of our vertex. So now I just sub this in to my original formula, and I don't know what k is, but I know what a is. It's 5 over 4. So it's going to be 5 over 4 times 1 plus 2 times 1 minus 4. So we're going to have 3 times minus 3. So we'll have 5 over 4 times negative 9. Because 3 times negative 3 is negative 9. Then it's going to be negative 45 over 4, which is our minimum value. So our vertex in this case is 1, negative 45 over 4. And the final answer, the minimum value is equal to, I'm running out of room here, negative 11.25. If you convert it back into a decimal. So the question here is asking us what the minimum value is, which means that in turn we're going to have to determine what the vertex is and the y value of that vertex. But in order to do that, we need to come up with some sort of formula. So we found our zeros from our graph. Then we plug that in over here. We plugged in our y-intercept, which we could see very clearly. Then we solve for a. Then we jump back over. We solve for h, because we need to figure out halfway between our two zeros to solve for h, so that we could then solve for k. So we solve for k over here by subbing in our h value. And the k value is actually our final answer. I wrote down the vertex just to over-explain this a little bit, and I might have confused you, and I apologize for that. If you have any questions, make sure you ask on the forum. That's the end of this cycle. Next week we will be doing an assignment, so there will be no new lessons. You can go back through your notes and look through them to help you through the assignment. If you have questions on that, I'll probably post a forum, and best of luck.